Hello everyone, my name is Ümit Işıkta. I'm a professor in Mimar Sinan Fine Arts University in Turkey. Today I'd like to introduce some interesting and also basic topics related to building information modeling. I have an experience of around 20 years on BIM. I started working on BIM in nearly 2000 in the new millennium. So it's now 2020, and I have been working with them for almost 20 years. Several things has changed, but the basics remained mainly the same in building information modeling. So I'll try to take you to a journey where we can discuss and understand what BIM, what building information modeling is, and what are the key concepts that make building information models an important asset for architectural engineering and construction industry. So I'll explain this with a presentation. The presentation will cover a journey into the BIM world through the questions of the basic concepts on BIM, building information models as the data, building information modeling as a process of information modeling and management, adoption of BIM, and we will look into the future of building information modeling. So what is BIM? It's very popular keyword in nowadays. BIM stands for Building Information Modeling or Management. So the B in this word, B, stands for the building. So although it's true that the approach has started from the building side, mainly from the buildings, now it has been extended into infrastructure projects as well. So we can rename it today as construction information modeling as well, because it's spanning through all different areas of construction industry. But keeping the basic principle of building, so it's related with something that's built. The BIM is really tries to represent the information about something that will be built in someday, or that has already been built. So there are two different types of information BIM can represent. One is a future projection. We can plan, we can develop a model, and then we can build the building. Or it's kind of a retro approach, that where we can actually use the information that has been already stored in some documents and transferred into BIM, where the building has been built, for example, 20 years ago or 50 years ago. So anyway, BIM, and the B in BIM stands for the building. Is this always true? Mostly yes, but I can assure you that there are several efforts to extend its scope to infrastructures and utilities. So we can say that although the name is BIM, it's now covering utilities and infrastructure projects as well. So the I, second letter in the acronym, stands for the information. So this is actually the keyword, the key element of the BIM, the I. Actually, there are many presentations, many talks about the I itself. Why? Because it's the main asset. The key point of BIM is the I, is the information. So why not data? Why not knowledge? Or in early stages of BIM, it has been named as BPM, Building Product Models. So why it's information? We have to think on this very deeply. So it's not data. It's not building data model, although it's more like data in some cases. So the keyword I, information, indicates us that it's more something that's been processed. So the data should be processed in some way before it has been stored in a building information model. So you can either design a model, or you can also either provide some information and process it somehow to actually make that information to become a part of BIM. So there is some processing beforehand, storage of information as a BIM. So the data, the raw thing, the raw idea, raw concept should be processed before it becomes a building information model. The I is the information there. Why not knowledge? Yes, there are several theories indicating that the storage of knowledge is something different. The storage of knowledge is more or less very near, very similar to the storage of experience, if you want to recall the experience. So it's actually the information. Yes, it's an information backbone where we store all the information, where we try to store. Actually, we don't store all the information, but we try to store all the information related to an AEC process, related to a construction process, construction of a building, construction of a facility, construction of an infrastructure. So we try to actually store, we try to model, we try to store with a model all the information. So this is the key concept. It's not the knowledge, because we don't, at the current date, as 2020, we don't really focus on storing the knowledge, the experience, the expert knowledge in that. But in the future, yes, why not? But today, the key focus is not storing the expert's knowledge. It's storing, the key focus of BIM is storing the information, the processed data in form of a model, as a part of a model. So while we are designing, while we are storing the information in BIM, building information model, we are trying to store the information in a structured way, in a structure, in an organized way, if you like. So if we like to store the information in an organized way, we need some structure. So the structure is actually a model. The model stands for, let's move on to the next slide, management and also modeling. So I will speak about modeling in the next slide, but first one is the management. So the BIM actually firstly focuses on, as a concept, management of information through the whole life cycle of the building. So we are trying to formulate a way to organize processes, to organize the information to be managed efficiently throughout the life cycle of the building, from conceptual design till demolition. So in this phase, we are trying to use the information, the I element in the BIM, the information in the BIM, to actually generate a DNA, if you like, a DNA of a building. So when we are constructing the second building, the third building, the fourth building, we can use the DNA of the first building. And the information stored in the DNA of the first building can be very helpful in the generation of the second building. We can say it's knowledge. We also store the errors in design, the problems in construction. We also try to store them as well. But it's not really, we don't store the information in the head of the engineer, in the head of the architect, but instead we store what has already happened during the design, what has already happened during the construction. So this is the edge that we come. We try to store the information and events that happen during the design and construction stages. So we are trying to build a DNA, a building DNA, building information DNA, if you like. So the other focus that we look into is we try to manage the information with a coordinated way. We try to manage the information, all these processes in the design, in the bidding process, and in the construction phase. We try to manage these processes through efficient use of information. Through, for example, in the pre-design phase, we try to make a lot of simulations to achieve greener buildings, leaner processes. We try to minimize the errors, and we try to solve the problems in the construction stage to be problems. They are not real problems, but we are trying to mimic the problems in the construction stage, in the design stage. So in the design stage, we're trying to generate these problems virtually. So what we do with the BIM philosophy is we try to generate a lot of problems in the design stage. We try to simulate them. We try to see what will happen in the future when we are constructing the building. What will happen? We try to answer these questions. We try to solve the problems in the construction stage when we are still in the design phase. So if we can solve the problems, most of the problems of the construction phase in the design stage, or in an earlier phase, I mean, we will have a lot of gains in terms of time and cost when the process is going in advanced stages. Like if you happen to have a problem in the construction, it's very difficult to solve. It's very not only difficult to solve, it's very costly to solve as well. So the main philosophy of building information modeling is to manage information. Is in a way, one, to have a coordinated design and coordination to solve the problems as early as possible in the building's life cycle. So we are focusing on, let me repeat, these are very important ideas about them. So first of all, we try to design and construct in a coordinated way, in a digitally, if you like, a digitally coordinated way. And we try to mimic, we try to simulate the problems as early as possible, like in the concept design, in the design, and but before construction. So with this in mind, I think another important thing about building information modeling is the modeling part. When I was talking about this BIM acronym, I was mentioning that the M stands for model itself and management. So if you go back to the slide and if we focus on the model itself, so I have been mentioning that we are trying to represent this information in a structured and organized, if you like, organized manner. So we are trying to represent the information, the I, in an organized way, in a way that everybody can understand easily, in a way that everybody can share this information, exchange this information easily. So the model is for that, the model is for enabling everybody, every partner of the BIM process to share and exchange information as easy and as efficient as possible. So if all the parties want to share information as efficient as possible, as easy as possible, they should make an agreement. They should agree on the way to share it. So every party agrees if the BIM process is implemented in the firm, in the industry, every party, every stakeholder agrees that information will be shared in this way, in this organized manner, using this rule A, rule B, rule C, document A, document B, document C. So we are formalizing the information sharing process. We are making it formal. We are making it agreed, if you like. We are making an agreed process, an agreement between ourselves as an industry professionals, agreement on the sharing and information and exchange of information. So we are making this agreement, and this agreement and the rules of the agreement, rules of how information will, how the information will be represented in this agreement is called the model. Once we have the model, we can make use of this model and also several process formalizations. The model is information formalization, if you like. The model is formalizing the information. Model is representing formalized the information in the building in a formalized way. But it's not enough, because we have to represent the processes, the way that we work in a formalized way as well. So we do not only represent the information about a beam, column, a slab, wall. That's not enough. So it should be supported with representation of formalized representation of the processes, the way that we do it, the steps of the process, the steps, the workflow. There are also many supporting BIM standards to actually represent this formalization. So the model is one way of formalizing things, and BIM standards is the other way of formalizing things. The model itself, the BIM, formalizes the actual information about the building, like the height of the column, width, the material, and so on and so forth. But the way, the method of construction, the method of information exchange, the method of documentation is formalized in different BIM, building information modeling standards. So, model, the BIM itself, can be also regarded as a virtual prototype, as also a twin, if you like. Nowadays, the very popular keyword talks about digital twins. So it's more or less the same concept that BIM is touching, actually. The digital twin is one-to-one representation and one-to-one real-time representation of the building. What we are talking about here is the information-wise one-to-one representation, but the digital twin is also information-wise one-to-one representation. But in the digital twin, every bit and piece of information should be in real time. So if you have a digital twin, you should know if the door in the building, if the door is open at the current point in time, or if the boiler is working in the current point in time. The BIM does not require that. BIM only represents that there is a door, the shape of the door, the material of the door, information about when the door will be constructed, when it will be maintained, and so on. So that's BIM. But we can use BIM to generate the digital twin of a building. We can use BIM to also contribute to the digital twin of a city. So BIM stands for, the M in BIM here stands for the modeling, for creating prototypes of the building, modeling for efficient exchange of building information, and also interoperability of software through the use of shared digital models. So another concept raises here is interoperability. So what is interoperability? The key model, key standard in building information modeling is called IFC, the Industry Foundation Classes. It's an international standard it's a formalized structure representing the information in the AEC industry, and it's a key standard, and it stands for Industry Foundation Classes. So the organization behind this IFC, the International Industry Foundation Classes, is named as Building Smart today. So the former name of this organization, the previous name of this organization was called International Alliance for Interoperability, IAI. So when you go into the roots of the IFC model, you will see a very critical keyword. It's called interoperability. Interoperability was the actual cause of BIM, actually. What I mean by that is the BIM has emerged. The original concept of IFC or BIM standardization or key information exchange need has emerged as a result of lack of interoperability between different software applications. So what is interoperability? Interoperability is defined as the process to interoperate, which means to operate others' function. So if we expand on that, what does it mean? So to interoperate, for example, let's say we have software A, we have software B, and when we make those two software interoperable, we somehow enable A to use the functions of B and enable B to use the functions of A. This can be done through several approaches. This interoperability can be achieved not only by using the data, but also using some programs, software, some coding. But in the BIM world, this interoperability or functioning on behalf of the other software can be done through data. The data here is our model. So in order to programs to interoperate, for example, they can use a dataset both can understand. So function A can be completed by the use of a shared data. Function A of software A can be completed by software B by the use of a shared data. So shared data, shared information is an important enabler of interoperability. So the BIM in its early days in late 1990s has emerged as a cure, as a remedy to the interoperability problem between software. At that time, it was very difficult to work on a shared digital model. Every software was having their own standards. It was very difficult to exchange the data. It was very difficult to work on the same data model. So in order to enable interoperability, the software companies have come together and have established an alliance, which is called the International Alliance for Interoperability, which then worked together to generate the standard BIM model, which is called IFC, Industry Foundation Classes. The organization is now, as I said before, named as Building Smart. If you log into their website, you can find many information and different information about Building Smart as well. Okay, so let's conclude this very brief introduction to BIM with a summary. So building information modeling can be defined as a management of building information. If we define it as a process, we can define building information modeling as management of building information through utilization of shared digital building models, which are unique per building. So BIM can be defined as this process, as a information management process, but this process should make use of unique digital building models or digital prototypes or digital twins of the buildings, which are unique for every other building. So we can call an instance of this unique digital model as the BIM, the Building Information Model. Both acronyms are the same, BIM. We can call the information management strategy as Building Information Modeling. This is also BIM. So there are there's a single acronym, but it's defining two different things. First one is the model, an agreed formal structure, an information model. The other one is a process, is a way of doing things by using a formalized model. So both of these two concepts are called building information model or modeling, but BIM. Okay, let's move on to the next session now. So we check the BIM as a model that enables software interoperability. Let's focus on the model side. Okay, so this is a model. BIM is a model that enables the interoperability. So why BIM is different? Why BIM is special? What makes BIM a BIM, if you like? So we have pre-BIM era. Actually, there again a new era, which was pre-CAD era, and then we moved from pre-CAD era to pre-BIM era. So let's speak about very briefly about pre-CAD era. In pre-CAD era, we were drawing by hand, by pen and paper. That's it, you know. So with the advent of computing and with the developments in processing speeds and screen technologies and input technologies and all those sorts of stuff, CAD became possible. So when CAD became possible, the keyword is also interesting, the CAD, because it's called computer-aided design. So once we are diving into CAD world, we accept that computers are aiding us. Computers are helping us in the design. Computers are helping us in the design. Computers are helping us in structure analysis, in cost calculations, and all sorts of stuff. Today, computers are helping us in every aspect of the AEC domain. But in the post CAD or pre-BIM era, CAD was the main focus. So CAD was actually a drawing tool, a drawing board, if you like, in the first stage when it first became popular. It was kind of a digital drawing board. It was the same approach that you were taking with pen and your paper as an architect or as a designer. It was the exact same approach that you were drawing the lines, you were using some different pens, if you like, different layers. Then it has become, the pen approach has evolved into layer approach and different layers. And then this moved into some sort of, let's say, pseudo 3D. Not real 3D, but pseudo 3D. Then it moved into real 3D as well. So it's the evolution of building information, evolution of CAD, if you like. So, but in standard CAD models, there are no semantics. Okay, what's semantics? Another concept. Semantics is the knowledge of meaning. Okay, so when we speak about semantics, we speak about the knowledge of meaning. So the standard CAD models do not carry information about a building element, because the CAD drawings does not tell us if this element is a door, this element is a window. They're only telling us that there are lines and there are combination of lines in a layer, which is named as a door. You can name the layer as a door, then we can understand, but it's not like you cannot, for example, differentiate as a computer. If you're a computer and if you have a CAD file, it's very difficult to differentiate between door 1 and door 2 and door 3. So there's not real semantics in terms of objects in the drawing. We can't speak about model in the CAD as well. So the CAD is the drawing, it's not the model. The data structure is not object-oriented, yes, because the data structure is more like the data structure of the files is more like drawing-oriented. It's trying to define the relations between the lines, between the areas, and in later days of CAD between the volumes. In the early days of the CAD, there were no 3D. Then, in the late times, CAD has gained the capability of representing objects in 3D. But again and again, these objects were 3D objects. It's all, nothing more than a 3D object. The relationships in space can not be represented in CAD. The relationship between, for example, what I mean by spatial relationship is the relationships like in the space. Although it also discovers topological relationships. For example, in a standard building, we know most standard construction types. For example, we know that the reinforcement bars are covered with concrete. Okay, so the relationship is inside relationship. So the reinforcement bars, for example, if we think of a very ordinary beam or ordinary column, and if we think of the bars themselves, the reinforcement bars, we all know that they are covered with concrete. So it's how reinforced concrete comes into life. So the relationship is inside relationship. So the bars are inside the concrete beam. Okay, so there's a concrete beam and the bars are inside the concrete beam. So in CAD, we can model this mathematically or topologically or spatially. You can draw. You can try to represent it with 3D at most, but the representation in terms of topology until recent times has not been stored until recent times. Okay. State information. For example, there is a model and there is construction going on. State information tells us if this, if you like, wall, if this wall has already been built or not. So the state information tells us if it has been already built or not, but CAD cannot tell us this information, cannot tell us this. But in BIM, you can check it and you can see if it has been already constructed on the site or not, if the information is input into model, of course. Okay, so the BIM is special. BIM is special. The BIM is more elegant solution to information management than CAD, and it's representing the building in a very much more information-oriented manner when compared with CAD, computer-aided design models. So how we can differentiate BIM from other digital building models, other CAD models, or any other digital building model? There are some principles here. First one is object orientation principle. The data structure of the model is developed based on the object orientation paradigm. So if you know a bit about software engineering and object orientation paradigm, you can easily understand this concept. The information representation structure, the structure of, or in other words, the structure of represented information is object oriented. So you can, if you're modeling a wall is modeled as if it's a real object. I don't want to deep dive too much into this because it's kind of very a bit more software engineering oriented subject. The second item is being comprehensive. The models are data rich, information rich, and comprehensive in terms of geometry and semantics. So in terms of geometry, the model elements are very, very, very detailed. So the model elements can represent door, window, or indoor furniture even. And when you check it, you'll see, when you check a BIM, you'll see how, for example, if you check the indoor furniture, you can see how detailed all the elements are modeled and represented in them. Also semantically, for example, if you are talking about a chair, and if the information is there, I don't want to argue that every geometry has advanced level of information, but if the information is there, and if you check a chair in the model or a table in the model, a furniture, you can view when it's produced, with the manufacturer, and so on and so forth. Okay, the BIM is 3D. That's it. It's very straightforwardly put. The BIM is 3D. That's it. What I mean by this is once you're generating the model, the BIM, you are generating as a 3D model. You're not generating something as a line or a point. No, everything, every object. Once you're modeling the BIM, once you're modeling the information to be stored as BIM, in other words, no, once you're modeling, when you're in other words, when you're making BIM ready model, you should do it in 3D. So, and there are 3D operations like CSG, sweeping, and boundary representation operations to actually construct the model itself. So when you're modeling an object, a wall, for example, you can use top view in a software, in Revit or ArchiCAD or Allplan. You can see what you're generating is in 2D. But once you change the view into 3D, you can actually notice that what you have generated just now is an actual 3D object. So today's BIM software, all of them, supports this 3D model generation. I was speaking about space relationships, and the relationships in the BIM are spatial. The geometry relationships are stored as spatial relationships. BIM supports view generation. So the model views are the subsets or the snapshots of the model that can be generated from the base information model. The views can be automatically derived respect on the user needs. So if we open up this a bit, a view is actually, if you're familiar with databases, it's more like the same concept. The view is a subset of the model. For example, if let's say you're an architect, I'm an engineer, and I want to see the elements related to civil engineering, related to structural analysis. So you can select the subset of the BIM and only work on the subset, and then you can update all your changes into the BIM, the model. So this submodel that we work in is known as the view. For example, structural engineering view, civil engineering view, or HVAC view. If you're a mechanical engineer and you work on HVAC elements, you'll work with the HVAC view. This does not generate oversimplification, but it prevents the errors of due to, if you like, work in a very complex visual environment or very complex information environment as well, not only visual representation but also information wise. Okay, so BIM, the building information model, is an evolving model. So BIM is shared between the project stakeholders and the owner through the entire life cycle of the building. So the principle behind the building information model is sharing. So since the concept design, starting from the concept design, starting from the first sketch of the architect, the information should be shared between all stakeholders, the owner, the architect, the consultant, the contractor, everybody. So we should share the information starting from the first sketch, starting from the first idea until the demolition of the building. So this sharing philosophy also should continue when you are or people are living in the building. So in this approach, the building information model, the actual information storage, BIM, acts as the information backbone or DNA of a construction project. So BIM enables the applications to be easily integrated into the process. The applications come and go. The model is constant. The model is our, let's say, landmark. The model is there. The applications come into the process, go out of the process. Application A comes, does its job, go out. Application B comes, does its job, go out. But the information, so the BIM, the building information modeling, actually declares us a philosophy of information is essential, or information is the key. Information is the key. This is the philosophy. So everything can change except an information structure. So everything can change, but an organized information structure should not be changed. I don't say here, please do not get me wrong, I don't say here that information shouldn't change. No, information can change, but an information infrastructure shouldn't change. Plus, process management infrastructure, process management infrastructure shouldn't change. The information can change, processes can change, everything can change. It's not, I don't say it's not flexible, but the infrastructure of information management and infrastructure of project management should be well organized and should not change throughout the project. So this is the BIM philosophy, actually. Okay, so the evolving model. So this is the DNA representation of that building information model, which says that the knowledge over time has been gathered through planning, design, build, operate, renovate, dispose, and demolition stage. And then this knowledge, the information, actually, this can be taught as an information. When we look at today, the AI and all these kind of new technologies that are coming up, it's not very logical to, although it's a bit of old slide, it's better to say information over time. And this information backbone has been built up through the exchanges, the information exchanges occur between many stakeholders. So the principle is maintaining a central product model, central information model, which represents everything, every bit and piece of the information in the construction process, in the design process, in the construction process. And all these information are stored in this model, and all these, as I mentioned just before, all these different type of software can import and export information from the model. So they can import information, use this information, process this information, and export newly generated information to this organized storage. So this is the organized storage, the product model, the BIM. Okay. I was talking about the views. So many different parties want to view BIM from their own perspective. These include the owners, planners, realtors, appraisers, mortgage bankers, designers, engineers, cost and quantity estimators, specifiers, lawyers, contractors, subcontractors, fabricators, when we say offsite manufacturing, code officials, facility managers, maintenance people, renovation, building managers, facility managers, disposal, recycling, environmental, plant operations, energy-related operations, leads, BREEAM, and space security network managers, CIOs, risk management people, occupancy support, and also emergency responders. So there are really many different people who are interested with the BIM. What can BIM include? So this is another interesting topic. It does not. So once we are saying what can BIM include, we should note that the BIM, we don't say the BIM must include this. It can include. So BIM can include site information, architectural program, floor plans, space functions, classified areas, area calculations, volumes, engineering calculation results, specifications, contract documents can be integrated into BIM. So, for example, integration of this requires the integration of document management software with BIM. This is also the same. Legal descriptions, change orders, supporting documentation for litigation, shop drawings, procurement documents, progress photographs. So these can also be integrated with BIM. Alarm diagrams, warranty data of any object inside the building, invoices, purchase requests, cost estimates, organizational occupants, personal list, seating plans, handicap designation, network diagrams, hazardous materials, operating manuals of many devices inside the building, maintenance records, inspection records in the FM stage, facility management stage, electronic 3D model of the building, simulations, continuation of our operational plan. So BIM is not an asset for design and construction, but it's an important and key asset for building management, for facility management, for operation stage. While we are living in the building, while we are traveling from the airport, the asset is there. BIM is a digital asset, and it is very important. So this is a disaster risk recovery plan. So if there is a fire in the building, if there is a flood, you can use BIM to actually plan or manage the emergency operation, contingency plans, and furniture inventory. So this list can be extended as well. There are other things that can be added to this list. So BIM can include many things. So BIM is important in the design phase to enable more coordinated design. BIM is important in the construction phase to check everything is going on program and everything is proceeded as planned. And BIM is important in the operation stage to check the building is operated normally. So at every different stage of the life cycle, BIM is important. There's also another dimension. This dimension is can be named as city information management today. It's called CIM, City Information Modeling and Management. And once you go up in the city level, these building information models, these digital representation of buildings, become the elements of a digital city. So digital city contains digital buildings. So the information on the digital buildings would and can be updated from the BIMs. So this is the key principle behind BIM and GIS integration. This is also a popular topic for last, 10, 15 years. In BIM, A model supports multiple analysis. So when you're using a BIM, you can do HVAC analysis, you can do structural analysis, you can do analysis related to architectural planning, and so on and so forth. So BIM can be used for many different analysis types. Let's move on to another subject. It's called the management of a project, information management of a project using a BIM, and we have to do some planning. This planning is called BIM execution planning. So the BIM execution planning tells us how to manage the BIM process, or in other words, how to manage information management processes using a BIM. So this is called project execution planning, BIM project execution planning. So once you have decided to use BIM, you have to do a project execution planning. So this project execution planning involves several steps. First, you have to identify the BIM goals and uses. Then you have to design BIM project execution process. You have to define your information exchanges, and you have to define a supporting infrastructure for BIM implementation. So BIM happens between the organizations such as the owner, the architect, the engineer, and the contractor and operator. And integrated BIM processes generate information exchanges. So this is the resource that I'm using is Penn State's BIM execution planning BIM execution planning guide. This guide tells us that the integrated processes generate information exchange, and we have to formalize several things. We have to formalize the processes, integrated BIM processes. We have to formalize the information exchanges, and the information model is also there. So information model is the BIM itself, okay? But as I said before, we have to formalize the information exchanges and integrated BIM processes, and we have to let organizations know about it. So all this process is called BIM execution planning. So I was telling you that there are several stages of the construction life cycle or building life cycle. The key stages are planning, designing, constructing, and operating the building. So there are several sub-stages, or there are several jobs to be completed in each stage. Some span into all stages as well, such as cost estimation, phase planning, site analysis, design authoring, energy analysis, and all these different aspects or different job groups are requiring different utilization of them. Okay, so if you're doing design authoring, you have to utilize them in a way to support your design authoring. If you're doing energy analysis, you have to utilize BIM in order to support your energy analysis. If you're using if you're in the construction side, and if you're doing 3D control and 3D planning, you have to utilize BIM in order to help you with your 3D control and planning. If you're doing asset management, space management, you have to utilize BIM in order to help you in space management. So you have to plan all these things. You have to plan all the uses of BIM. So depending on your use, you have to make an organized plan on how to use this BIM for that specific aspect. For example, you have to plan how you will make use of BIM for design authoring. You have to plan how you will use BIM for energy analysis. You have to plan how you use BIM for structural analysis. You have to plan how you will use BIM for 3D control. You have to plan how you will use BIM for asset management. So all these plans are called BIM uses. Okay, so simple approach to BIM-based project management is this. First, define the BIM uses. Second, define the stakeholders. Draw a sketch process map. Identify which software to use. Identify your integration approach. Is it model-based interoperability or model-less interoperability? Which I mean interoperability through the use of BIM software, but not the model. Make iterative improvements and capture, gain knowledge. There are challenges in each step in defining BIM uses, in defining stakeholders. Process mapping should be, there should be trained people in your organization to define a really good process map. So what software to use? Which integration approach you will choose, for example. How would you complete your iterative improvements, and how would you capture, in which system you'll capture it again? So there are challenges now in every step. Although we are able to manage all those issues, in terms of our organization, it's also important to have an adoption. So the organizations, this is from Bill and Richards, 2008 to 2020, so the organizations should find them a place into this evolutionary chart. So they were the kid era, they should move into level 1 BIM, level 2 BIM, level 3 BIM, and they should learn, they should have a process of learning on how to adapt to them. So these are the key important concepts that can be mentioned as a start point to BIM. So with this, I'd like to conclude my presentation, and I'd like to thank you all for listening to my presentation. Wish you all the best in your studies in your university, and hope you'll enjoy your BIM journey in your organization and in your professional life. And thank you very much, and I hope we'll meet in person in some time, and hope to see you in person. And thank you, and bye for now.